complex numbers in the field of mathematics and especially in the field of electrical engineering is very important. By introducing an imaginary component, which is often represented by the letters I or J, it makes it possible to do a lot of complex mathematics and come up with a usable solution. And when I talk about electrical engineering, for example, we're going to have phase shifts that come into play. And so the complex numbers allow that to work out quite easily for us. Now, when we work with complex numbers, what you're often going to find is that there will be reference to a rectangular as well as a polar format. And the rectangular format just is going to be x plus jy. If you were to get the polar format, that's going to be r with an angle of theta. Now, if you look at the sketch at the top left-hand side, that is where x is going to fit in. So that's going to be on my horizontal axis, and that's typically going to be my real number. Y is going to be the imaginary number, and that's going to give us the vertical axis. You can see the angle theta that has been put in. And so the last part that we need is going to be the r. And that is where we are going to get the polar or the rectangular format. Now, it's very easy to convert from the one to the other, but it's even easier than the method I'm going to show you, and that's just to use your calculator. Take your calculator and put in your calculator model number into ChatGPT and ask it for the instructions, because these differ from calculator to calculator, and you should be able to come up with the right equation. It makes it so much easier, but I'm going to do it manually just to show you how it does get done. So looking at the screen in front of us, you can see that my horizontal value is going to have a value of 4, and the vertical value is going to have a value of 3. If I was to go and write this down as rectangular notation, I would write this down as 4 plus J3, or I3, depending on whether you prefer to use the I or the J. It's going to differ from mathematics and electrical engineering. I prefer to use the letter J. So that is going to be in the rectangular format. We're going to have 4 plus J3. Now, what we're trying to get is the polar notation, which is going to make use of R and theta. In other words, we want to try and get R with an angle of theta. And in order to do this, we're going to use what we did on the previous 2 videos, which is to have a look at the trigonometric equations. You will remember the formula that I always come back to, a little acronym which says some old horses can always hear their owners approach. Now, I am looking at the opposite and the adjacent, and together they are going to work hand in hand with the tangent of theta. And so as a result of that, I can go and say that the tan of theta is going to be calculated as the opposite divided by the adjacent, which means that the theta is going to be the inverse tan of the opposite divided by the adjacent, which is going to be the inverse tan of 3 divided by 4, and that is going to give me a value of 36.87 degrees. So we've just gone and calculated the value of theta as having a value of 36.87 degrees. We now need to go and get the value of R. In order to get the value of R, we're going to go and make use of Pythagoras. And you would recall that Pythagoras is going to tell us that R squared is the same as the sum of x squared plus y squared. And therefore, R is going to be calculated as the square root of x squared, which is 4 squared, plus y squared, which is going to be 3 squared, which is going to be the square root of 16 plus 9, which is going to be the square root of 25, which is going to have a value of 5. We've now got the angle theta, and we have got the long side R. So we can go and wrap up this exercise. If we're looking at the rectangular format, we can go and put that down onto the equation. Let's go and use the black lettering and say that the rectangular, in this case, is going to be equal to the 4 plus the J3. And that will be the rectangular format. And we have gone and calculated the polar format. And in our case, the polar format is going to be a value of 5 with an angle of 36.87 degrees. So there you can see how we've gone and converted from the rectangular to the polar using trigonometric equations as well as making use of Pythagoras. Again, I'm going to reiterate that if you use your calculator, it is a lot easier and a lot more accurate. And that, in a nutshell, was the conversion from the rectangular format to the polar format. Please go back to previous videos on trigonometry and Pythagoras just to refresh your knowledge.